You're listening to a special episode of Energy Insiders, hosted by Giles Parkinson and brought to you by GE Vernova. GE Vernova is accelerating the path to more reliable, affordable and sustainable energy in Australia and around the world.
Hello and welcome to this special episode of the Energy Insiders podcast. My name is Giles Parkinson. I'm the Editor-in-Chief of Renew Economy, which combines the Renew Economy website itself, the EV Focus, the Driven and One Step Off the Grid. And in this special episode, we interview Jackie Brown and Aaron Scott from GE Vernova. GE, people will know, been around for more than a century, one of the biggest and once the biggest industrial company in the world, and build up a sizable energy business, which just over a year ago, was spun off and renamed GE Vernova. And they are looking at Australia, amongst other countries, as one of their big expansion opportunities, and with good reason. Their focus is on wind and battery storage, hydrogen and gas. So for all those reasons, Australia is a big tick for those developments. Anyway, I took an opportunity to sit down with Jackie and Aaron and had a discussion about their technologies and how they see the market. Jackie Brown and Aaron Scott from GE Vernova, thanks very much for joining this podcast special.
Thanks for having us.
Jackie, let's start with you. You're the with Aaron. You're the co-chair of the GE Vernova Country Council, and you're also the head of its wind business in Australia. GE is a name that we've heard for more than a century. It's a massive company expanding in so many areas. GE Energy has now morphed into GE Vernova. Tell us a bit about the scale of it. And I guess why Australia is such an interesting location for it.
So GE Vernova is essentially a purpose-built energy company that was spun off from GE Company coming up to 1 year ago now. We have 75,000 employees globally that are focused on the energy transition. Why we look at Australia, GE Vernova and Australia both share that goal of balancing affordability, reliability and sustainability. There's an abundance of natural resources here, and Australia is also focused on actively transitioning towards a low-carbon economy. So it's just a couple of reasons that we see Australia as a strategic market for us. Our operations here, as you alluded to, extend back 125 years. When we were originally here as part of General Electric Company, we initially provided infrastructure for tramways and bridges. You fast forward to today, we have over 400 employees in country, half of them are engineers, and we have our software helping to run 80% of the electrical grid in Australia. So even though we're just getting started as a standalone company, we look forward to another 125 years of partnership with Australia.
So, Aaron, what makes Australia particularly or different to other markets? And I'm just kind of interested in your technology mixture that you offer here in Australia. Why have you chosen those? As my understanding is, apart from some of the back end stuff that Jackie's mentioned, your principal technologies and supply technologies are based around sort of gas, wind, and battery storage.
Yeah, so I guess the key thing here for the Australian market is the enormous growth in renewables, which has really transformed the energy system, and obviously GE Vernova is a key supplier of some of the core technology, wind turbines, for example, hydro turbines as well. And Australia is really leading in that space, and so our technologies are really an ideal fit for the market. And I guess as we go through the energy transition, one of the key things that's changing is the need for flexibility. So in the case of our gas turbines, one of the key changes that we've seen in the market requirements around that flexibility for things like fast start, fuel flexibility, high cycling capability and part load capabilities as well. So I guess one of the interesting things about the Australian market is, as we go through the transition, the need for some of that new technology and how that's then change the way we apply it.
Yeah, it just sort of seems in a way sort of this sort of moving away from what we sort of used to describe as sort of baseload power, some of those sort of coal-fired power stations, those sort of mid-market or intermediate gas-fired power stations. I mean, that sort of focus on flexibility and dispatchability, that sort of it's a different way of looking at the grid, and it creates more opportunities.
Absolutely.
GE Vernova was named as the supplier for one of the world's most innovative, I guess, gas hydrogen projects in Whyalla. You are going to deliver turbines to deliver 100% hydrogen capability as part of the hydrogen jobs plan. That project seems to be put on the back burner or the side burner because of the need to sort of rescue the Whyalla Steelworks, as it were, in the initial phase. I'm just kind of interested, though, about that technology. I mean, one, maybe you can just sort of clarify what those turbines are going to happen, how you understand the situation is there, whether it's just sort of put off for a while, or whether you're going to be sort of giving those or selling those turbines to another market. But I'm also really interested just to find out about that capability of making turbines which are actually 100% green hydrogen.
So for us, from a GE Vernova perspective, our contractual arrangements haven't changed. So we are still manufacturing and supplying the turbines for the Whyalla project. I believe the state government has announced that they will look to resell those gas turbines in the future. But I guess the key thing for us is that one of the core requirements of that contract was that we had to uh, build a carbon copy of the plant in Greenville in South Carolina, and that gave us the capability to fully test and commission a unit on 100% hydrogen. So even before the units arrive in Australia, we'll have established and proven that the LM6000 Velox is 100% hydrogen capable.
Yeah. I mean, how much of a sort of a technology change or technology advance or change has that been? I mean, is it a new way of making turbines? Is it about repurposing turbines? Can you give any more detail on that?
The core turbine technology remains the same. It's mainly around the actual combustion system. So there's some key challenges around the combustion system that have to be addressed, and then obviously things like safety. So putting in additional safety systems and controls around the hydrogen.
And you've had any sort of other demand for those sort of those hydrogen turbines? I mean, it might be sort of too early in that transition of the hydrogen economy to get much pickup at the moment. But where do you see that heading? Maybe in Australia or even overseas?
Oh, we're still seeing very strong demand in Australia. Virtually every single project uh, either has a hydrogen requirement or wants us to ensure that we have a pathway to 100% hydrogen as the supply of hydrogen grows. So it's definitely a core requirement in Australia, and that's being reflected also in other markets globally as well.
Mm. Well, gas and batteries, and we'll come to batteries later on in this discussion, but gas and batteries are going to form the sort of the principal sort of technologies that will deliver the sort of the flexibility and dispatchability in a high renewables grid. You guys are obviously just sort of doing sort of more conventional gas turbines, the fast start turbines. We've heard a bit of discussion recently about the backlog in orders. Where do you see that market from your position? If someone wanted to go out and buy some turbines now, and how long would they have to wait?
You're 100% correct. The market globally has grown significantly, particularly in areas such as the US, Middle East, and parts of Europe. So for all OEMs, actually, the supply chains are uh, a little bit stretched, and so our lead times are pushing out. So I guess the key thing for us is that we're working very, very closely with our customers in Australia to support them and ensure that um, they're planning ahead so that we can still align supply with their needs. But it is true, it's quite challenging at the moment.
Mm. Jackie, I wonder if we can move on to wind technology now. You're the head of the wind business in Australia. You've Two most recent contracts are pretty interesting. There was Flyers Creek, I think, and there's also Boulder Creek. There's a big passion about putting creek on names of renewable projects at the moment. I'm not too sure why. But I'm kind of interested in the contrast between the two because Flyers Creek was just recently built, but it's got relatively sort of small capacity turbines, 3.8. And yet your Boulder Creek, I think, is probably going to be amongst your biggest that you've brought to the market so far, 6 megawatts. Can you explain what the difference is and why?
Yes, that's right. So Flyers Creek came online near the end of last year. That did have our 3.8 megawatt turbines on it. And that was really in line with the approvals that the customer had for the site there. When we look at Boulder Creek, that reached financial close near the end of last year, first project finance, split scope contract in Australia, so a big milestone for the market overall, and that did have our 6 megawatt platform on it. Um, in Australia overall, about a third of the units that we're providing already are linked to that 6 megawatt workhorse platform. That is one of two key platforms we have globally. The other one focuses on the US market. And we've really lent into this workhorse strategy over the past few years as the best way that we see to deliver the volume required at scale across the globe. So, with that, we look at how do we continue to bring quality and performance through that repeatability, reducing the complexity, able to create more efficient and sustainable supply chains with focusing on two of those key platforms. And then our customers get the benefit of that technology based on the long cycle validation that we have. For that platform specifically, it's actually the most deployed nameplate above 5 megawatts in the world if we look outside of China, and we've got over 200 million operating hours on that at the moment. So we expect to see that deployed in Australia for some time to come.
Mm. And this sort of actually, just before I move, I'm just sort of fascinated about this. I can't quite remember how you described it, but that sort of innovative finance facility, and I was a little bit intrigued. I'm just wondering why it was actually such a landmark. Maybe you can just sort of very briefly describe what it was and why it was so interesting.
So historically in Australia, we've seen the majority of wind projects come under EPC contracting, where you have really one party that supplies the turbines, civil, electrical, balance of plant, everything under that one contract. Um, Moving forward, we see the market pushing towards splitting up scope into multiple contracts. So although there are a few wind farms in Australia that have been delivered that way, they were generally done on a balance sheet. So to be able to go to the finance market and demonstrate that they are also comfortable with this contracting model is what makes that such a big milestone for Australia.
And where are we headed in Australia in terms of sort of cost and supply challenges and things like that? I mean, we sort of just talked with Aaron about some of the issues in the gas turbine market. I think wind. I'm not too sure. I suspect that the wind turbine market is also fairly competitive at the moment. One, just in landing contracts in Australia, and then two, for developers to actually sort of secure the technologies, the towers, and the turbines.
Yeah, I think, maybe the gas business is slightly more challenged than wind at the moment when it comes to supply constraints globally. I think the benefit that we have in Australia in the wind business is it actually is very long cycle. So it's easy to get the signals from the market as to when you're gonna have to have technology available for a project, and that can you can right size to that quite easily. The challenge that I think we see more and more in wind at the moment is actually more on the local supply chain side of things. So, the cost of BOP in the country continues to climb, labor rates continue to go up. Do we have enough vehicles to deliver all of the equipment? Do we have enough cranes to install? I think that is where we kind of start to get towards a tipping point here.
Well, that's interesting, yes, and particularly the transport cost. I mean, it's quite a spectacular thing to see those sort of huge turbines and those blades getting sort of moved across the country, but it's just an incredibly logistical challenge, isn't it?
It definitely is, and we see you move from state to state, different regulations, different permits, different processes across all of them, which adds to that complexity as well.
Yeah, and one of the biggest deals you've landed is with Squadron Energy. I think you perhaps you just remind me about the scale of that deal. I mean, is it usual to sort of land a sort of a contract with a big developer which has got multiple projects coming up, and Squadron Energy probably ranks amongst the most ambitious developers in Australia in terms of what it wants to do over the next decade. I think it's definitely above 10 gigawatts. It's probably up to 14 gigawatts of wind and solar. Is that normal to, or how common is that to sort of land an exclusive arrangement, if you like, with a single developer?
Yeah, so the agreement that you're referring to with Squadron is a 1.4 gigawatt strategic framework that we signed with them at the start of 2024. Um, and really, that was looking at a couple of pieces. So, how do they create certainty of supply as they go forward and want to deliver projects faster? And then it also brings, I think, for everyone involved, the benefit of being able to focus on the projects and optimize and get the best out of project in the meantime, because you already know who you're working with from early on. Not necessarily something we have seen in Australia to date, but we do have a couple of other agreements like this around the world with other partners as well.
And presumably trying to land some more such agreements going forward.
We would be very happy to.
And I'm wondering if we can come back to you, sort of getting back to that sort of flexibility and the sort of dispatchability around a high renewable grid. We've talked about gas. GE Vernova has landed some significant battery contracts in Australia, most notably with the Supernode project in Queensland. That's a relatively new thing for GE Vernova, isn't it?
Yes, it is in the Australian market. I guess it's a very exciting project for us. The Supernode project is a $2.5 billion data center and energy storage complex in Queensland that's being developed by Quinbrook Infrastructure Partners. And as part of that project, we're providing the flex inverter, which comes as a pre-packaged 20-foot container, and it includes the inverter, uh, medium voltage transformer, switchgear, all integrated, pre-wired, pre-tested. So it's a very highly modular and easy to install solution. And then along with that, we're providing the Flex IQ power plant controller, which is based on our well-proven Mark 6E control platform. So really exciting project for us, and we're looking to build on that and expand into similar projects going forward.
So essentially, that you're actually sort of providing the smarts for these for these projects. Then I guess that's a good way to describe it.
Yeah, so we act as an integrator, I guess. Yes, you're right. We provide the smarts, and then we can work with a number of pre-qualified battery suppliers and provide that overall integrated solution.
And we've heard a bit of talk in recent months about the sort of the cost of battery storage falling down. Are you sort of seeing that in your from your suppliers? I guess you have the opportunity to sort of pick and choose.
I think with any technology, as it starts to mature, you'll see it come down the cost curve, absolutely. And I suppose in a similar way to what we've seen in both wind and solar, that will happen over time.
And we've actually did an interview with Quinbrook's David Scabrook on this podcast a few weeks ago, and his focus, which was really interesting, was on the interest in longer duration batteries. I think the initial Supernode, I can't quite remember now, was it 2 hours or 4 hours? But he's certainly talking about putting in an 8-hour component in the Brisbane one, and then building these other 8-hour batteries around in Queensland and New South Wales and possibly even the Northern Territory. What's your view of sort of longer duration storage?
I think that's definitely a potential option for the market, and it will sort of align with some of the other technologies that are out there, such as pumped hydro as well. That fits that similar sort of dispatchable short duration range. Um, so I think there's a lot of technologies that could fit into that space, and they're all quite complementary. basically they're there to sort of bridge the gap, I guess, until you'll see gas peakers start to pick up and supply energy when it is needed for much longer durations. So I think what we'll see over time is that batteries, pumped hydro, those types of solutions will be there to supply the almost instantaneous response needs and provide that frequency support. And then gas turbines will move into that longer duration role where there's a need to provide power when there's no wind and solar for longer durations, days or weeks.
Yeah, okay. And obviously sort of GE Vernova then having the turbines for gas and for pumped hydro and the smarts for the battery storage facilities have got their feet in each camp.
Yeah, we try to be technology agnostic and provide solutions across the market.
Jackie, I was just wondering if we can come back to you with a couple of questions I sort of did mean to ask about wind turbines. And, we talked about the 3.8 megawatt capacity at Flyers Creek and then going up to the 6 megawatt capacity at Boulder Creek, which seems to be sort of the workhorse for you sort of going forward. What about in the future? Do turbines need to get bigger, or do you think that they might get more capacity and power out of sort of similar size and height? So I guess there's sort of two questions here. One is about the height of the turbines, which may be an issue for people living near them, and then there's the amount of sort of capacity that you can actually get out of them, and therefore project developers look at these equations to work out, the best option for them in terms of sort of investment and finance and yield and revenue, etc.
Yes, I think as we move forward, we will still see turbine size increase at least a little bit. I think when you look at the height of turbines overall and the fact that really the best wind sites in Australia have already been built and you're now looking at the next level of sites that come behind that, where you have the sites that have a higher shear, it definitely would benefit developers to go higher with the turbines, regardless if you're changing the nameplate that they're being built with. And I do think we start to see on some of the projects the height of the towers pushing up just now. Overall, I think the other things that we do need to consider when looking at how much bigger turbines get is what are the other constraints in the market that are put on us. So things like, can you actually transport a turbine as it gets past a certain size? Blades in particular, already over 80 meters long. How much bigger can you go to get them to sites?
That was going to be my question next.
The BOP is very expensive in Australia. Some projects are starting to hit 50-50 on BOP versus turbine cost. How much more can you sustain there?
Just to clarify, that BOP being balance of plant, for those not intimately involved in the industry, that's an interesting statistic, actually, sort of half and half the cost of balance of plant, which is, all the other infrastructure that you need and the roads and the transport and things like that, and the actual cost of the turbines. How does that compare to other countries?
I think in Australia we see it as quite a high cost country for balance of plant. And to be clear, that 50-50 is really something that we're seeing on very complex sites at the moment. If your site is not as complex, you would see that drop, maybe 60-40 for turbines versus balance of plant. Historically, it was 70-30. So that price has been creeping up. Other countries where you can have, particularly a lot lower cost of labor, that difference can be significant. So it is a big factor in Australia when you consider what can be built going forward.
Is that something that can be addressed? I mean, does GE Vernova have some sort of policy recommendations that could that could address that, or is that just kind of like the state of the economy, the high cost of labour and transport and what happens? I mean, before I interrupted you, you're starting to talk about permits and things like that. I'm just wondering if that's part of the equation that could possibly reduce the balance of plant costs.
I think that if you streamline things like the permit system overall, you're going to benefit the cost of the wind farm in totality, which is going to help offset any other potentially rising or just generally higher costs that you see. Some of the things that we would look at as we develop a turbine as well is how can we design this to better work with balance of plant? Can we make a foundation smaller, for instance, which is going to take cost out? Are there new technologies coming that can help innovate and reduce those numbers going forward as well?
Okay. And one last question about wind turbine technology. What is the potential then for local manufacturing in Australia? Some components, and nacelles, possibly, towers, blades. What's possible?
Yeah, that's a question that everybody loves to ask. And unfortunately, it's quite a challenging piece to look at. I think one of the main things with local manufacturing is it requires consistent throughput. And in a country like Australia, where we wouldn't be competitive if we were exporting components without high levels of any government support that we don't have today, that makes it a big challenge. So we've historically been a very lumpy market in Australia. You take last year as an example, 6 wind farms, I think, reached financial close. The year before, 2023, only 1 wind farm did. So that doesn't really provide the stability that you need to create that case for localization. And then you take the challenge of stability and then, that's not actually looking at some of these additional challenges that you have of cost, quality, and available labor in the market. If I take, blades, for example, that you mentioned, it's a very labor intensive workforce that's required. So perhaps the best way to liken it is to shipbuilding. You're in a full hazmat suit, you're sanding blades by hand. Um, I think finding the workforce that wishes to do that in Australia in 30 odd degree heat would be challenging for everybody.
That sort of takes us on to the policy area. Now, we are just at the start of an election campaign in Australia, so no one, I don't think, wants to get too political. But some of the just basic sort of key policies that would withstand either party being there. I mean, what are you sort of looking for in terms of stability? It could be sort of overall policy, or it could be things to do with just the management of the grid, the connection process, which in Australia is well known to be reasonably complicated. I wonder what's sort of top of mind for GE Vernova on that line.
Yeah, it's a great question. I guess for GE Vernova, the key thing for us is around stability, political stability in terms of the energy policies. We'd like to see a long-term policy framework so that there's certainty in the market. And I guess that helps our customers to be able to develop their projects, having that certainty around the policy framework. And one of the key areas to do with that would be in terms of grid compliance and getting that grid connection. That does tend to be a very challenging area in Australia.
Anything from your point of view, Jackie, on your wish list of things that you'd like to sort of see?
I think it's probably no secret, right, for anybody that the renewables industry as a whole has lived through so much churn from differing government policies over the years, but everybody has kind of pushed forward regardless in the industry. So I think anything that can just create a bit more stability and give those clear signals to investors that Australia is a place to come and put your money would be helpful for everybody. And anything that can streamline approval processes and make things clearer and faster is really going to help the industry continue to grow.
I mean, I guess it's probably true to say that we're in the midst of this quite extraordinary sort of green energy transition, this sort of transition to renewables. And this is actually new for everybody, whether they're sort of developers, equipment suppliers, massive OEMs like GE Vernova, policymakers, regulators, just about everyone. Everyone's kind of learning as they go. It must be. well, it is for us as the media sort of looking on. It's really quite fascinating.
It definitely is, and it's keeping all of our government relations teams very, very busy at the moment as they work through some of the dynamics daily. Um, but the best thing we can do is set a clear path and continue on it. I think that if you continually to change policy month in, month out, that uncertainty just scares everybody away.
Yeah, yeah. I'm just wondering, there's one sort of final question. Just, you talk about the attraction of Australia as being sort of, in the midst of this transition. And in many ways, Australia is kind of sort of leading in some forms the absorption of rooftop solar, just the management of sort of high renewables on the grid, the sort of uptake of battery storage, the adoption of pure hydrogen turbines. In what way is the sort of the world, or even sort of people like GE Vernova, looking at Australia as, I don't know whether it's fair to describe it as a test bed, but as a centre of innovation from which they can learn?
I think that's absolutely the case. We are seeing, for example, in the gas space, there is obviously hydrogen has been a key development that Australia has led, but also around some of the codes and standards associated with gas compliance. I mentioned the grid connection. Australia's world leading in terms of the requirements around grid connection, grid modelling, etc. And a lot of that is actually being transferred. The learnings and the knowledge that's gained here in Australia has been transferred to other jurisdictions globally as well.
Yeah. Jackie, do you have something to add there?
Yeah, I was just going to build on Aaron's point about the grid code in Australia. That is a standout example for us. Um, Definitely one of the highest hurdle rates to get connected here, but we see a lot of other countries starting to adopt similar standards. And the amount of focus and attention we've given Australia to ensure we build that world class grid team here is really benefiting us as we work with other network providers globally to be able to have equipment that can connect anywhere in the world.
Okay, well, fascinating stuff. Jackie Brown and Aaron Scott, thank you very much for joining this podcast special, and good luck. Good luck with the contracts in the future.
Thanks for having us, Charles.
Thanks so much. Thanks for having us.
And that was Jackie Brown and Aaron Scott from GE Vernova. Thank you very much for sponsoring this podcast. And you will find the regular episodes of the Energy Insiders podcast on this platform. Please do have a listen. And thanks for listening. Bye for now.
You've been listening to a special episode of Energy Insiders, hosted by Giles Parkinson and brought to you by GE Vernova. GE Vernova is accelerating the path to more reliable, affordable and sustainable energy in Australia and around the world.